Hi! Have you ever wondered how Angular is designed internally, which design patterns are used, and how everything works under the hood? In this video, I'm going to dive into the source code of Angular, where you will see how HttpClient is designed, how HTTP interceptors are applied, which design patterns are used there, and how certain features like withRequestsMadeViaParent are working under the hood. My name is Dmitry, and I create in-depth Angular tutorials and courses, helping people to become advanced Angular developers and level up their skills. And I will be happy to walk you through the Angular source code. So let's get started. Before diving into the source code, let's take a look at the high-level overview of the HTTP client, because it will definitely help you to understand the source code later. So, HTTP client. Many developers think that exactly this service fires the HTTP calls. This is not entirely true. Actually, the responsibility of HTTP client is to normalize and prepare the request according to the configuration we provide via the HTTP client API. For example, when we call methods get, post, put, delete, etc. So HTTP client transforms our configuration objects into certain data structures that will be eventually used internally. So once the request is normalized and prepared, the request processing is delegated to the so-called HTTP handler. HTTP handler is actually an abstraction that might have multiple implementations, where each implementation must have a method called handle. Theoretically, there might be multiple implementations of it. However, as of now, there is only one implementation represented by the HTTP interceptor handler class. As you might have understood from its name, this handler is responsible for applying interceptors to the request. But then it should perform HTTP call, right? No. After applying the interceptors, and how exactly it happens I will show you later in this video, the HTTP handler delegates further request processing to the HTTP backend. HTTP backend, it is also an abstraction which requires each concrete implementation to implement the handle method as well, which will be responsible for firing HTTP calls. And because we have multiple ways to fire HTTP requests in modern browsers, this abstraction has already got multiple implementations. The default one is represented by the HTTP XHR backend class, which fires HTTP calls using the XML HTTP request object. But there is also a fetch backend implementation that uses fetch function under the hood to perform HTTP calls, and there are some other implementations that can work with other type of requests like JSONP. Which exactly implementation will eventually be picked depends on your configuration that you provide for the provide HTTP client function. Now, let's see how it looks in the code. So let's get started with the provide HTTP client function implementation, because it is an entry point for HTTP client configuration. As you can see, it defines a group of providers, and many of whom are already familiar to us. This is the HTTP client service itself. This is the HTTP interceptor handler that is used as an implementation of the HTTP handler abstraction. And here is the provided HTTP backend token, the implementation of which is resolved inside the factory function, where by default we choose HTTP XHR backend implementation, or if you use the with fetch function inside your HTTP client configuration, then it would provide fetch backend token, the value of which one will be actually the implementation of the HTTP fetch backend class. All right. And now let's take a look at the implementation of the HTTP client. And as I said, its responsibility is to prepare and normalize the request you want to perform. For example, when you call the get method of the HTTP client, then internally it passes your configuration to the request method, which eventually parses your configuration provided as an object into data structures like HTTP headers, HTTP params, and eventually it creates the final HTTP request class instance with the normalized data for the further processing. Once it is done, the request object is passed to the handle method of the HTTP handler, which is being injected in the HTTP client constructor. We will get back to this place and see how the response is handled later on. But now let's follow our request and jump into the HTTP handler implementation, which is resolved to HTTP interceptor handler class instance. So here it is. And among other things, it injects HTTP backend, which is responsible for kicking off the HTTP calls, and by default it is supposed to be resolved to HTTP XHR backend. And now inside the handle method that HTTP client calls, the following two things happen. First, it collects and applies interceptors to our requests. And the second thing that happens here, the processed request is delegated to the backend's handle method to perform HTTP request and return a stream of HTTP events that our backend returns. I intentionally dropped how exactly interceptors are handled, and I'm going to get back to it just in a few moments to break it down separately and see which design pattern is used there. But now let's see one of the implementations of the HTTP backend, and namely I'm talking about HTTP XHR backend. Its handle method is actually pretty complex, so I will highlight only key points here. Here, everything starts from a stream of the XML HTTP request object instance, and then we use it in order to open connection to a certain URL with a certain method like get, post, put, etc. Everything depends on what configuration we get from the HTTP client, right? So then we set headers and other stuff, and finally the configured request is sent, and immediately a corresponding event is emitted from this stream via the observer next method. Other events are sent in a similar way by dedicated callback functions that happen at certain point. For example, when the request is loaded, things like body, header, status, etc. they're extracted, combined into HTTP response and send it as a response event and completes the stream. By the way, this stream where those events are emitted, this is actually nothing but stream initiated by the HTTP client's request method right here. And now, once we send request to the server, our flow is split into two paths. The first path is when we configure our HTTP call via HTTP client with the property observe equal to events string, then you receive this stream of events and you're supposed to handle everything on your own. Otherwise, what happens in most cases, under the hood, HTTP client filters out all events except the HTTP response, because this is eventually the only thing we are interested in. And once we get it, then depending on the response type, it handles the response accordingly before it will be propagated to you. For example, if it is a JSON response type, then the map operator will be applied that will extract the body from the response so that you don't need to do it manually. All right, so that was pretty extensive walkthrough of the HTTP call journey. And now, as I promised, let's take a closer look at how HTTP interceptors are being applied. So here is the source code of the withInterceptors function that you call in order to register interceptors. And the only thing it does is turn an array of provided interceptor functions into the HTTP interceptor functions token that is actually a multiple provider. So by injecting this token, you get an array of all registered interceptor functions within the injector where they are provided. This is exactly what the HTTP interceptor handler does inside the handle method by injecting this token from the common environment injector. And then when all interceptors registered in this particular injector are collected, then happens deduplication of the interceptors, and all duplicated interceptors, if they exist, they are being removed. After that, all those interceptor functions are composed into one chained interceptor function. What it does is take the request, pass it to the first interceptor, and the transformed request is passed to the next one, and so on. And then, when request passes through all interceptors, the final handler function is called, which eventually delegates request to the HTTP backend in order to perform HTTP call for the request that was modified by the HTTP interceptors before. I cannot say that I'm a design pattern guru. However, as I see, it is a classical chain of the responsibility design pattern. The idea of this pattern is to pass sequentially a certain entity like request through the chain of handlers, where each handler knows which actions has to be performed against the request, and then it either passes a request to the next handler in the chain or completes the chain. Basically, this pattern consists of the handler interface, which is in context of Angular represented as an interface with a name HTTP interceptor function, and each function that implements this interface contains the interceptor logic or implementation, right? And this handler gets a reference to the next function, calling which one we pass our request to the next handler in the chain. And then in order to execute this chain, we would need to have something like a loop that will build a chain of interceptors and pass requests through them. Now, as a bonus part, as I promised, I'm going to cover the source code of the withRequestsMadeViaParent function, which allows you to chain interceptors with the parent injector and fire HTTP calls via the parent HTTP backend. So if you are unfamiliar with this feature, I would highly recommend you to check out my previous video where I explained exactly this feature, because it will help you to better understand what we will be talking about. So what does this function do? Well, it performs a very simple but elegant task. This function overrides the backend implementation for the current injector with the HTTP handler from the parent injector, which actually has the same interface as HTTP backend. This means that whenever the HTTP handler inside the child injector passes the request through the child interceptor chain and finally delegates it to the HTTP backend, the HTTP backend in this injector will be resolved to the parent HTTP handler instead of something like HTTP XHR backend, etc. And as you remember, HTTP handler is responsible for applying interceptors registered in the common injector, which means that the request will be passed to the interceptor chain from the parent injector, and only after that the request will be delegated to the HTTP backend, specifically the one from the parent injector. And again, I'm not a design patterns guru, but to me it looks like a typical implementation of the strategy pattern. It is when you have multiple algorithms, multiple strategies that have a common interface. In our case, it is a HTTP handler interface, and it allows you at runtime swap the implementation depending on certain conditions. If you are curious what other design patterns are used internally in Angular, you can check out my other couple of videos where I also dive into Angular source code and show how different design patterns are applied in Angular codebase. And even more similar in-depth tutorials I have available exclusively for those who support my channel on Patreon or here on YouTube via YouTube membership program. Right under this video there is a button, clicking which one you can join YouTube membership program. In such a way you can support my channel and get access to exclusive videos and early access to the upcoming videos. This approach with source code investigation I also use quite often in my video courses dedicated to different Angular topics like Angular forms, and if you're interested you can check out those courses as well. Links will be in the video description. Otherwise, thank you for watching this video until the end. Please share this video if you find it useful, and of course leave your comments. I wish you a productive week ahead, stay safe, and see you in the next video.